Hello, hello, everyone. Happy Saturday. Welcome to the Strange Parts Show and Tell. How's everybody doing out there? Hello, hello. Who we got? Hey, Box Kid. Good to see you here. Hey, Obsidian. Hey, Steepcast. Hey, Sako. Hey, Fube. Hey, Christus. Welcome, welcome. Hey, Esden. Long time no see. Glad to have you here. I think you'll be interested in some of the projects we got going on today, particularly the first one. How are things going, Esden? Long time no talk. Hey, neither skills nor style. Welcome, everyone. What else am I missing? Hey, dreams are fragile. Oh, I'm glad you joined for some other streams, Esden. I just didn't see you then. Hey, Rambling Geek. Hey, Coffee Cart. Welcome, welcome. It is going well, all considering. It's been a hectic week. I have been really struggling with the iPhone modification project I've been working on. I am now up to 5 brand new iPhones, which hopefully will be it. It's getting to be expensive, but I'm making progress. I feel like I have some understanding of what the heck I'm doing now, and now it's more a matter of executing. One of the challenges I've been facing right now has been measuring 01005 passives, resistors and capacitors, and that is proving challenging. The main issue is getting contact with them with probes without shooting them across the room and into oblivion. So, oh, awesome, Esden. Yeah, sweet. I think a lot of people kind of co-work during my streams, so I'm glad to have you here, whether or not you're in the chat. Yeah, we should absolutely talk. I'd love to catch up. So you know how to get a hold of me. Ping me and we'll find a time. Would love that. And we should have you on as a guest at some point. Show off what you're working on, because you're always doing cool stuff. Do some cross-pollination here. Yeah. Coffee Cart, I do have an additional business card for you. We can work that out. If you're going to be at LTX this year, so am I. Again, so maybe we'll bump into each other there. Yeah. So yeah, I've been trying to measure these 01005s. We've been talking about it in the Discord chat in the electronics channel about how to do that in the best way possible. And I'm definitely taking like a belt and suspenders approach. I'm going to build like an enclosure around my microscope, because I can really only measure them under the microscope. They're so small, I can't really see them well enough with my naked eye. And build an enclosure so I do shoot them somewhere if they're contained. Maybe with a like a jeweler's apron, basically a piece of fabric that comes out from the front of the desk to my waist and ties around my waist, so that there's like a catch area there, and then you know, like a backstop. And then I've got these tweezers, these measurement probe tweezers, but they're very, I don't know if you can see, they're very big tips on them. And so the thought has been either to solder sewing needles to the tips or to grind them down. So these are super cheap ones. They were only $5 on Amazon. So I'm going to try both approaches. I've got 2 of them, so figure that out. Yeah. And then I've been interviewing candidates for a shooter editor position. I'm down to 3 folks. So really excited about that. And I got some really good people that I'm talking to, and just need to make a final decision here. And hopefully that will dramatically increase the rate of videos I'm putting out. So I'm really excited about that. And then, yeah, dealing with some stuff with the Patreon. If any of you are members above the $15 tier level, you can go check Patreon for all the details. But I'm just trying to figure out some quality issues with the merch. We accidentally shipped out some really low quality t-shirts and hoodies, which I was aware of that they were low quality, and we were trying to figure out a solution. But they shipped them out without me knowing. So now they're shop rags for anybody who's received one, and working on getting set up with a new source of higher quality clothing. And that's turned into this really interesting manufacturing rabbit hole, which is that the service that Patreon is using, Printful, does DTG, direct to garment printing, which is where they print directly onto a finished garment. with like an inkjet process, similar to the UV printer, except I don't think they use UV to cure. I think it's heat cured. There are some peculiarities about that process that turns out just results in low quality. So Printful, I've sent Printful pictures of the samples they're sending me, and they're like, "Yep, that's to be expected." And I'm going, "This is crap." So true to Strange Parts fashion, we're not going to let you guys wear crappy T-shirts out in the wild. That would not be appropriate for a channel that is partly about manufacturing. So we're probably going to end up doing silkscreen and get some really nice T-shirts and hoodies going. So if you would like a T-shirt and hoodie, the only way right now to get one is through Patreon. So you can go to patreon.com/strangeparts. And that money really is going towards hiring folks. So helping me get videos out the door more quickly and to you, so that we're just making more stuff. Because man, do I want to be making more stuff. So folks, some folks are saying the video quality is low, and I know what's going on. Let me fix that. Thank you for the heads up here. We'll get that fixed real quick. Maybe 1 minute. Remember my password. Oh, now the thing. Okay. I had my connection bonding off, which means we are Starlink only right now. Is that DigiKey, of all places, does not like the connection bonding. They see it as, I don't know, people are probably scraping them from servers nearby or something like that. But I have a dedicated server that's doing connection bonding over 2 VPNs, essentially. One over a wireless point-to-point network across the valley, and one via Starlink. And they have decided that the IP of that server, which appears to be my IP when I hit the public internet, is not one they are comfortable with. So I get a 403 if I try and run any DigiKey searches. So, yeah. I should be back now. Mods are saying I dropped for 2 seconds, but I should be back now and the quality should be better. Is that true? I appreciate everybody's heads up here. Give me a shout in the chat if the quality improved. I'm not seeing any chat right now. 4K, okay. Sharp as a tack. Okay, great. Good. We're in business. Awesome. Fantastic. Glad to hear it. All right. Yeah, sorry about that. It is because I'm living rurally and up in the mountains. Our internet connection here is a little bit of an engineering feat. We don't have any service lines, copper or fiber that come to the house. We have twisted pair copper from the telco, which I think can do like 3 megabit DSL, which I'm not willing to pay for. So anyway, awesome. See all the beard hairs. That's how I know the camera's in focus, when I can see beard hairs. So that's legitimately what I look for when I go to manually focus a camera. So awesome. Good to go. So let's get to our first guest here. We've got a really exciting lineup today of 3 awesome projects. But I want to jump right into it. So Yannick, it looks like you're ready, but give me a thumbs up if you are. Okay, sweet. So we're going to invite Yannick on here.
Hey everyone.
There, Yannick. Welcome to the Strange Parts Show and Tell.
Thank you for having me.
It's great to have you here. I briefly read through your description, and this looks quite exciting. So tell us a little bit about what you're working on.
Okay, if you like, I can talk a little bit about my project, how it came to be, and maybe demonstrate it a little bit later.
Yeah, that sounds great. And maybe also give us a background for the space that this is in. What are other people doing as well? Because I'm not super familiar with this space, and it looks like you're at the high end of what's happening here.
Mm-hmm. Okay, I can do this.
Yeah.
I am developing an open source force feedback system for steering wheels, for example. So steering wheels, for example, like you are seeing here. and also something like joysticks.
Okay. Yep.
Yeah. So
Yeah.
in general, the idea is to have a very modular system where users can build their own force feedback devices and choose their own motor drivers, for example, and just mix and match whatever they have to really make their own dream force feedback setup.
Oh, this is cool. This is super
So
cool.
yeah, and as far as I know, at the moment, this is the only really fully open source project where only also the software and hardware is open source.
Yep.
In general, the idea initially was to make it affordable and modular. Back then, a few years ago, yeah, I really kind of got a little bit back into sim racing and saw what other people were building, and I wasn't really that happy with the commercial options. I really didn't want to justify spending a lot of money on a plastic steering wheel, which is pretty much toy quality. So
Yep.
I quickly discovered direct drive steering wheels, which is basically you take a big fat industrial servo motor and slap a steering wheel on it. And so people were using a project called MMOS, which
Okay.
was pretty much just a firmware for one of these ST development boards,
Okay.
which was a normal gamepad with force feedback extensions, right?
Sure.
Didn't need any drivers. This is pretty much also what I'm doing at the moment, but it could only output PWM. And it was closed
Okay.
source, and the developer has pretty much given up on the development back then. But there were
And
also,
PWM to the servo?
yeah, to the motor driver.
Yeah.
And
Motor.
most of these industrial servo drivers, they do not take PWM, but instead need a 0 to 10 volt analog voltage.
Oh, okay.
Yeah. So this requires some translation, and I wasn't really happy with this option. There were a few commercial devices which did use this firmware actually from that guy who made MOS. And if it was
Interesting.
open source, I probably would have just modified it. But I wanted a digital communication between the motor driver and the controller to
Right.
really have the best resolution, right?
Sure.
So, yeah, I started looking into a few options. And of course, I was a student and I wanted it cheap. So I thought, hey, why not make it with stepper motors?
Okay.
There was actually a steering wheel, a commercial one, which used a stepper motor, the AccuForce, I think.
Okay.
It was quite expensive, but it showed me that it is possible. But the problem is, for a steering wheel, you of course need really torque control. You don't need position control. You need real FOC. You want the user to turn against the force, and it should be smooth.
Right.
This is not something stepper drivers can do.
Sure.
So my first idea was kind of to make some pseudo FOC with a normal step direction stepper driver by tracking the position of the stepper motor and then sending a burst of steps to align the electrical angle of the stepper driver.
Okay.
It did kind of work, and it resulted in my first actual PCB I have designed.
Yep.
This is this one. This is the only one left, and I haven't touched it since I started the OpenFFBoard project, which is my current project,
Nice.
because it did work, but the resolution was just 7 bits with this stepper driver. It's a ST power step,
Amazing. Okay.
and
Yep.
yeah, and it was not
And
made
so you're getting
to.
does that result in very jerky motion?
Yeah, just in very low resolution force steps. So 7 bits was the resolution of the internal current control because I needed a
But
stepper
what does
driver.
what does that
Which-
feel like to the user when you're actually at the steering wheel?
So if you have very bad resolution in the current sensing and the current control, then when you want a very low force, like when you have a steering wheel with a spring force and turn it in the center, then you feel the steps when it gets stronger.
You sort of feel clicks or something.
Yeah, right.
Okay.
So that was not great.
Yep.
It felt better than some of the toy-grade commercial options, but it was not really fit for a steering wheel. Also, the stepper driver didn't like this mode of operation. And I think,
Yeah, I can see that.
was it 3 or 4 years ago on Maker Faire Berlin, I showed this, and it started burning in front of the visitors. And that was embarrassing. Yeah,
Awesome.
which is why this is the only one left.
We probably had it on for longer and had more use at Maker Faire than you ever had, would be my guess.
Yeah, right. And
Yeah,
it didn't like it. It was really on the edge of what's possible with this one. So I scrapped the idea with stepper drivers. I said, no, I don't care about the budget now. I want it great. So instead, I started the
So
OpenFFBoard
before you move on, I
project.
have a question, which is how are you measuring position? Because you were using kind of a feedback loop between the position of the steering wheel and the commands you were sending to the stepper motor.
Yeah, so I used an encoder. I put just a big encoder on the back of the stepper motor.
Okay.
So this is the same thing I am still doing now when I move on. You need a high resolution position source, of course. You cannot just use a stepper motor.
Yeah.
So yeah, I think back here, let's see. So this was the stepper motor I used back then. So it's just a normal stepper motor with an encoder.
Normal. I mean, a stepper motor that's this big, I wouldn't call normal, but sure.
Yeah, a pretty big motor. Right. I think in NEMA 32 should be 32.
Okay.
So yeah, this is a really big stepper motor.
Okay.
So
and just so I'm clear, I'm curious about the feedback loop. You were, as you wanted to add more feeling of resistance on the wheel, you're basically you're adding more commands to the stepper to turn again in the direction of, or against the direction of force?
No, back then, what I did to set the strength was I sent a command via SPI to the driver with the current I want. So it was a 10 amp stepper driver. So this driver was able to configure the strength, the holding torque.
Okay.
Which was why I chose this one. Yeah.
Okay.
And
holding torque. Okay. So you're just telling it to hold position, and then the user is fighting against that.
Yes, but I am moving the electrical field while the user is turning it. So that you don't skip these steps. So it was rotating smoothly. It just stepped further, right? So it always had the right electrical angle. Like FOC, but not really.
Okay.
You notice why I moved away from this idea. It was complicated, not that reliable. It's not what I'm doing now.
Got it.
So now instead, I started the OpenFFBoard project completely from scratch. I always had in mind my own motor driver, which was really made for this application. So this is the current version. You have this control board, which is basically also just an STM32 with a few headers and not much more, pretty similar to the standard development kits, just in a different form factor. So it's really cheap to make and simple to develop with. And this allows me to also have a PWM output, so it's compatible with the old MMOS builds. Has a standard encoder input for ABN encoders, and also a bunch of button and analog inputs to map to gamepad buttons and axes, and also a few SPI interfaces and a CAN bus. So really, the focus is connectivity in this case.
Yeah.
Yeah. And the new motor driver I chose is now a Trinamic TMC4671, which is a dedicated FOC motor driver which can drive stepper motors with 2 phases, 3-phase servo motors, and also standard DC motors. It has inputs for a normal ABN encoder, Hall sensors, and sine cosine analog encoders. So it is really a very, very flexible motor driver.
Esden is pointing out that maybe we need to explain what FOC is.
Yeah, right. FOC is field-oriented control. So that means you have the electrical phase of the motor inside the windings, and you are creating a force in a certain vector. And if you want to apply torque to the motor, you want the electrical field to be 90 degrees out of phase with the mechanical position, so it is pulling the rotor in a certain direction.
Got it. Okay.
So the electrical field always follows the position of the motor, which is contrary to a stepper motor. Different, a stepper motor will just open loop, set the electrical field to a certain position, and the rotor just snaps to the next step.
Right.
This is how a stepper motor works. And for a closed loop servo motor with FOC, the electrical field is moving smoothly. So
I see.
if you have 0 torque, then it will just spin freely. But if you set a certain amount of torque and turn the motor against the force, then it will, in every position, have the same force, the same torque applied.
And it will
which is
be
what you
moving
want.
that electrical field to create that force, that sort of force offset. Yep.
Yeah. The electrical field is always moving with the mechanical position. So this is also something normal RC style ESCs cannot do, because they are just using back EMF for commutation.
Yep.
But in this case, you really need a very high resolution encoder on the motor to do this.
Got it. Got it.
Yeah, and this is what the TMC4671 can do in hardware completely independently.
Oh, that's cool.
And it also has position and speed control modes, which I am not using in this case. So it really is, it is a really integrated motion control solution.
Yep. Oh, that's interesting. I didn't realize you were getting that all essentially for free on the chip. That's
pretty much. It is still very, very difficult to use this chip, unfortunately. Much more complicated than actually what I did with the stepper setup back then, because it has no memory, it has no internal alignment routines or so on. You need to calibrate the ADC every time. You need to align the mechanical and electrical fields every time by, for example, making a burst of flux in a certain direction, and then the motor follows. Then you have to calculate the offsets. So it is a really quite complicated setup sequence.
Okay.
I can show you how it
So
looks
if I say
like
getting
later.
it for free, that's not really doing justice the work you put in here.
It does it independently, but
Yes.
not easy, unfortunately.
Got it.
It is really
But it is not
complicated.
touching the processor, I think was more what I was going for.
Yes.
Yes, got it.
If you send it a certain torque and it's set up, then it will hold this torque, no matter what you do. So it's completely independent. It really frees a lot of resources on the processor. Unfortunately, I've seen a message in the chat about absolute versus incremental encoders. This is a drawback of the TMC4671. The TMC4671 does not support digital absolute encoders, like BIS-C, for example. There are workarounds to get this working with our project, also with the TMC, but it doesn't do this independently in hardware. So,
interesting. Even though it supports a position mode.
Yeah, well, it would use an incremental encoder for this. So it just counts these steps, for example.
Yeah.
So you can use a ABN encoder, like 40,000 counts per revolution is a standard high-resolution ABN encoder. This is supported.
But it
or analog
requires
encoders.
calibration on initial startup to know what your starting position is.
Yeah, it requires the alignment sequence, and you also have to manually center the steering wheel, for example, because the driver doesn't know the actual position. So yeah. There is a mode to set the electrical field in the TMC and not use the encoder interface. So this is a workaround I did to allow users to use BISC. It is just reading the BISC position with the STM and then streaming it to the TMC.
Oh, okay.
So this requires a lot of resources, unfortunately.
Yeah, sure.
But it is kind of a workaround to be able to support this type of encoder. So this really makes this system work with every encoder, which I can implement in software in this case.
Awesome.
Yeah. So this is pretty much how it is at the moment. This is also because it supports stepper motors, why I have 4 half bridges, which is quite unusual. And this is also why I had to use individual gate drivers. I have seen a message about the absolute center. It would support the index signal on incremental encoders. Most incremental encoders have an index pulse. So it can, for example, do an index search. It rotates the steering wheel one direction. And when it hits the index pulse, it knows this is the reference position. Then I can, for example, reload an offset from the flash, and the steering wheel will snap into place.
Awesome.
This is usually what most commercial steering wheels also would do.
And this is standard on a relative encoder or an absolute encoder?
Relative ABN encoder.
Oh, okay.
An absolute encoder, like BISC, for example, you start it up and it knows its absolute angle.
Right. Yeah, got it.
So this is, for example, what most high-end steering wheel manufacturers like SimuCube would do. Actually, I might be a little bit a spoiler, but back here, this is for people who know a SimuCube 2 Pro, and I have removed the original driver from it, and I have connected my own TMC to it.
Oh, awesome.
So it uses the steering wheel and SimuCube motor just as a motor in this case.
Nice.
And they use the same BISC encoder as Milch, a Chinese manufacturer of servo motors, which are commonly used for these types of projects. They are using the same encoder from it. So I already had support for this.
Nice.
So let's take a little look at other devices I can make with it.
Yeah.
If you like.
Yeah, that sounds great. Yeah, perfect.
So I have to move the camera a little bit.
Screen here.
So I have already shown you that it supports the TMC and stepper motors. So this is a little stepper motor with a sine-cosine analog encoder on it, which was just for demonstration. A tiny little steering wheel using an O-drive S1.
Okay.
So it also supports O-drives.
And O-drive is brushless, right?
Yeah, the O-drive is a three-phase motor driver, also an open source project. The newer ones are not open source, but this one, you probably know this. Many people will recognize this one.
Yeah.
It was also cloned a lot.
Yes.
But it is a really nice two-axis motor driver for robotic stuff. It's very nice.
Yeah. That's how I've run across it, was actually BattleBots.
And
we used
also
Wesps, but O-drive was much discussed. Can you explain
the VESC, right?
Yes.
This is
Can
also
you explain
supported.
the difference between brushless and stepper?
So in this case, when I say brushless motor, I'm referring to three-phase motors, like this one. So RC motors. Maybe I can. Let's see. I have one here. Might be easier to see this. So this is what I'm referring to. So these RC style three-phase
very familiar
motors, right? And stepper motors are actually two-phase motors, but also brushless. So just means it's not a brush motor, and the the motor driver will have to do the commutation, so switching the phases of the motor.
Right. As opposed to a
which
brushed
is-
motor that's sort of got a fixed
Yeah.
sequence of pulses based on the actual mechanics of the motor with brushes that touch the
Yeah,
the
right.
commutator. Yeah.
So yeah, with a brush motor, the motor itself does the commutation with brushes.
Yeah. And so when we talk about commutation, really what we're saying is when are the different when is the polarity to the coils in the motor changing, and who's driving that? Is it
Yeah,
being
right.
done in software, or is it being done sort of mechanically in the motor?
Yeah. So yeah, the polarity of the coils in the motor. Yeah.
Yeah.
Just where the current is flowing.
Yeah.
Yeah, and on the topic of motor drivers, yeah, you said also the VESC,
Yeah.
also another FOC capable three-phase motor driver, which also has a CAN bus interface, and this is also supported by the OpenFFBoard firmware.
Nice.
So yeah, you can use the VESC, you can use the O-drive, you can use a PWM output, our Team C motor drivers, and I can show you the software later with the selection, how it looks like. But these
Yeah.
are all motor drivers you can use with this firmware and make a steering wheel out of it.
Awesome.
And yeah, O-drive Pro as well, but the Pro has some issues at the moment, which I
Okay.
am not going into that deeply.
Sure.
It's kind of a little bit slower than the old one and closed source,
Okay.
but they are working on it. I'm in contact with the developers.
Awesome.
Yeah, so what people might be interested in is what this is. This is
Yeah.
the actual steering wheel. I have also documented this build completely on YouTube, how I made this steering wheel.
Awesome.
This is a SEM HR115 servo motor, 115 millimeters. And for some reason, someone on eBay in Germany sold these servo motors for around 100 euros a piece.
Oh my God.
I
That's a
have
bargain.
no idea why. I had 3 of these in my hands, gave
Oh.
them to other people and so on. Now they are gone. But for comparison, the encoder in this servo motor is a Heidenhain 1325, I think.
Okay.
Basically, it's a 500, 600 euro encoder.
For just the encoder.
This
What would
motor,
a whole new one cost, do you think?
this motor, 1,500 euros about. And at the moment, they are going on eBay for, I think, 500-600 used.
Wow.
And they are
what a bargain.
discontinued. They are 15 years old, most of them.
Yeah. Okay.
Yeah. And this is
Amazing.
The encoder is a sine cosine encoder and also an absolute NDAT encoder, but NDAT is a closed protocol. I cannot support this. It's not documented, so
That's
I'm using
unfortunate.
the sine cosine interface of this motor instead, which has 2048 phases. And oh yeah, right, the Team C actually has 16-bit ADCs. It's something I haven't told you previously.
Wow.
So this makes the current resolution also extremely high and also results in an analog resolution with this encoder of, in theory, 135 million positions per revolution. Which is insane.
That's wild.
And obviously it's not the correct resolution because of analog noise and scaling and so on.
Sure.
But this is what the motor would report. And it's more than enough for a gamepad resolution of 16 bits, right? So yeah, let's turn it on. I have turned it off because it's quite loud. The fan is running then. It's releasing the brake. Now it's doing the calibration sequence for the ADCs of the encoder. Now it is aligning the angle and checking. This movement was checking that the rotor actually follows the electrical field.
Yep.
And now it's aligned. Obviously, this is an analog encoder which has no index, so it doesn't know the position. So I have to manually center it by just holding it in place and pressing a button.
Yep.
Or I have to use software for it.
Yep.
And now it is an actual steering
that's
wheel.
so cool.
And it has a virtual end stop after
Yep.
900 degrees of rotation. So it's really like hitting a physical end stop.
That's awesome.
And it's really extremely smooth and completely silent compared to some other commercial options which always have some kind of coil whine. This
Yep.
is, depending on the motor, it is fully silent. The only thing you currently hear is the fan
Awesome.
of this
That's
power
amazing.
supply.
So
Yeah.
how much torque can this thing? I mean, is this at max torque? Is this something you could ever fight against?
This motor, yes, but it depends on the motor. This motor is quite weak, but otherwise very fast. I can show you the speed after this.
Sure.
And this one will do about 15 Newton meters.
Okay.
Most-
I don't have a great intuitive sense of how much that is, but
Yeah, so let's say usually Logitech or Thrustmaster steering wheels, they do about 5 Newton meters,
okay.
which is not that hard to fight against. So at the
Yeah.
moment, it is set to, I think, 10 Newton meters, and I can turn it beyond this with one hand. It is difficult, but it's possible.
But possible.
So-
okay.
It will not break your fingers with one.
Yeah.
But there are some other motors I also have back there in. There are some motors which would easily do 30 Newton meters.
Wow.
It depends on the motor and the power supply how much you can push, and
Yeah.
also of course the motor driver. My Team C driver, it is currently set up. This one is set up for 30 amps
Okay.
at
That was asking answering one of
50,
the questions.
60
in chat.
volts.
Yep. Wow. At
so-
50 or 60 volts.
Yeah, this one is currently running at
geez.
50 volts.
Okay. 50 volts at 30 amps. That's a fair bit of power.
Yeah, that's quite a bit of power.
Sako's asking, what's the big power resistor on top? The big orange.
This resistor, because the issue is with a steering wheel, you are turning it against the force. So it is acting like a generator. And
Got it.
so normally when a motor generates power, you need to dissipate it or charge a battery. So a VEC, for example, would, if you have a battery connected, just charge the battery. But I'm using a power supply in this case. So the Ultrawipf also has one of these braking resistors. This is to dissipate the current. There's an input diode, so the current doesn't flow back into the power supply and trip its overvoltage protection. Instead, I'm constantly monitoring the voltage, and when it rises above a certain threshold, it just pulses this resistor on.
Got it.
I can show it to you in the software as well. Let me switch to the desktop view.
Oh, nice.
This is my software. My config tool. It has a command line, so you can just send it commands. This is just you can control it completely via human readable commands.
Nice.
You have some config options. You can add button sources like the digital pins. These are just the pins on top of this STM board. And they can be forwarded as gamepad buttons.
Okay.
So
that's cool.
This is just pretty much what you see here. At the moment, you also see this axis jitter. This is because the analog pins are active. Now they are inactive and they don't do anything.
Okay.
And one of these axes is, of course, the position of the steering wheel.
Yep.
It doesn't need any drivers, if I haven't mentioned that. this is using just standard HID with the physical
that's so
interface
cool.
device standard. The standard was
You really don't have to do any software to get this up and running on your
No.
custom build. That's
yeah,
awesome.
I mean, you have to configure it. It is
Sure.
quite in depth to configure it, but it doesn't need any drivers. For example, it uses the physical
That's
interface standard, which
awesome.
was defined in 1999 with Microsoft. Back then, when most force feedback devices were MIDI.
Yep.
Yeah.
Nice.
So this modular approach in the software also allows the user to select different button sources like digital pins. Via SPI, you can connect buttons with just standard shift registers, which are used in Thrustmaster steering wheels, for example. You can connect a shifter, like the Logitech G29 and G27 shifters. They go to the analog inputs, and then it reads the position of the shifter stick and generates button presses based on that.
That's awesome.
Also I2C, this is a port expander, and you can also use a CAN message to set buttons. Same also for analog. You can also send CAN messages to set analog access. This is just to make it really modular. You can enable and disable this also on the fly.
Awesome.
I have a few YouTube videos about this, how this all plays together, but it really dynamically allocates the buttons in the gamepad report.
That's awesome.
Yeah. And has a lot of tuning options for the effects. Also, these are the effects. I have to go a little bit more in depth with the effects if you want.
Yeah, sure.
Maybe I can do this after we demo a bit.
Sure.
So the PID system uses predefined effects, which the game can play, for example. This is the Access tab. There I have different motor drivers to select from, like ORTMC, PWM output, VO drive, VESC, and Simple Motion, which is a protocol from Granite. Granite is also making the SimuCube steering wheels now.
Okay.
So people sometimes had their old builds with MMOS with the Granite Ioni drivers, and Simple Motion is a digital protocol, so people could communicate with their existing drivers digitally now.
Yep.
And yeah, this is the TMC 4671 config tab, and in the middle, of course,
which is the motor driver.
Yeah, this is the motor driver in this case. This is what I have selected in the motor driver access setting.
Got it. Yep.
This is this board down here with the caps. So this board I've talked about previously. This is the TMC 4671. And as I previously said, it supports DC motors, two-phase steppers, and three-phase motors. It's also something you can select here. You have to configure the pole pairs, of course. And these are different encoders this TMC supports. ABN encoders, sine, cosine, three-phase analog encoders, Hall sensors, and the external encoder function. With the external encoder function, you would have to select here, if you select a different motor driver, for example, now let's turn it off. Now you can select different encoders, like BIS-C, for example. And this is what would then be forwarded to the TMC. And I can switch motor drivers on the fly. Now I've enabled the TMC again. Let's see. I hope there's not a bug and it properly aligns now. And you see the flux ramping up in the calibration sequence. Yeah, now I have to align it again by clicking.
Yannick, this is really impressive. How long have you been working on this?
About 2.5 years at the moment.
It shows.
I think
it shows.
Almost 3 years.
This is impressive. This is awesome.
Yeah. This, I mean, sine cosine encoder, you have some options here. PI tuning is something you have to do. Recently, I was working on a automatic tuning function, which is not that great yet, but I mean, it does a kind of good job. TMC also has filters integrated, which basically just low-pass filters the torque signal I'm sending to it.
Yep.
It's not really
Oh,
that
awesome. We have
interesting.
Bother in the chat, who is another Twitch streamer, electronics Twitch streamer, who has worked on a similar project around steering wheels. So he said, oh my God, this would have saved me from reverse engineering the wireless steering wheel.
Which one? Like the SimoCube one? Because I did this. I reverse engineered the SimoCube steering wheel module.
Yep.
Like,
SimoCube.
Let's see. Actually, I have a cube controlled steering wheel here with Bluetooth.
Nice.
And this uses a module from SimoCube. And I wrote a Python script which translates the Bluetooth LE protocol into virtual button presses for VJoy, for example. So if you're interested in that, on my GitHub there is a gist, and which is a pretty basic script.
Oh, Bother says he did the exact same thing. It sounds like you guys should talk.
Yeah. The protocol is pretty simple, but I really don't get why they didn't make it into a just standard Bluetooth gamepad.
Yep.
It just makes no
He said,
sense.
I made my micro speak LIN bus and then also faked the SimCube into thinking it's Bluetooth low energy.
Did you want to send button presses to the SimCube or use the steering wheel as a gamepad?
I'm not sure. We'll let him respond here. Chat. I occasionally caught the stream around it, but I don't have a ton of context on his. It says it unlocks more buttons to press digitally.
SimoCube also reports 128 buttons in their report, which is the maximum you can send via HID. I have limited to 64, but I mean, it doesn't really matter. I'm just using 64 because it's currently easy to store in a 64-bit int. But I go to 128.
Yeah. Oh, Bother, if you want to join the stream and join the conversation here, you're welcome to. One of the mods can set you up. We're happy to have you on.
Yeah.
I'm happy to have you on. So yeah. It sounds like you can ask even more in-depth questions than I can on this. This is awesome.
Some games only like 30 buttons because this is also only what Windows shows you. So this is quite interesting. In the Windows preview, you see only 32 buttons. But actually, my device is sending 64 because the Windows dialog was never designed to display more than 32. But in fact, the standard would support up to 128.
Oh, wow. Oh, that's wild.
Some game developers think the standard only supports 32, so they limit it to 32.
Oh, that's wild. Oh, Bother's going to join us on the stream here. He's switching PCs and he's going to chat with us here. So, yeah, this is awesome.
Yeah. All right. Let's get back to the TMC. You can also select different current sensors. So in this case, I'm using a 30 amp current sensor. The ACS 724, which is 66 milliwatt per amp. But you can also select different hardware versions, which sets some internal scalars in the TMC. It's not really that great, but it was the easiest option for me to make it by not having to set some GPIO jumpers on the boards directly and wasting pins. So kind of like this.
That's awesome.
So this is pretty much the feature of the TMC driver. But I also want to show you how it reacts. So this is a testing tool.
God, you've written a lot of software.
I have not written this software.
Awesome.
This is just from iRacing. This is not my software. We have to go into the effects now after I did this. I select a spring effect. So the spring effect is calculated on the device. And I'm also selecting a damper effect.
Okay.
Um,
Oh,
and
wow.
when I now turn the slider, the steering wheel moves.
Oh, wild. And
And
so
it's
this is how
really-
you get the, like, when your car spins out, you get the steering wheel spinning underneath your hands kind of thing.
Yeah, yeah.
Got
But
it.
most games are not using the spring effect. So you can see really how fast it reacts. It twists my
That's
table.
wild.
It has
Yeah.
a lot of torque. And it's running at 50 volts at the moment. This motor is actually rated for 600 volts.
Oh my God.
So yeah.
What's your motor controller rated to?
It kind of depends on the components I choose, but it will, in this configuration, allow for 70 volts. I have limited to 65 because some components don't like more than 65.
Okay.
So usually anything up to 60 volts is fine. And here you can also see in the corner the currently measured voltage. So this is related to the thing with the resistor. You see the input and the motor voltage. The input is before the diode, what the power supply supplies, and motor voltage is behind an input diode.
Oops. Hang on. Sorry, I screwed up the camera. I was trying to move myself out of the way here.
And when I turn this, you see that the motor voltage goes up to 55 volts.
Got it.
But the input voltage does not go higher. And when it goes, the internal voltage goes 5 volts above the power supply voltage, then it triggers the resistor. And it limits the voltage to 55 volts in this case.
Got it. Okay. And so it's just shunting current off to the power resistor.
So if you were looking at the oscilloscope, you would see this resistor pulse on and off and some spikes going down to limit the voltage.
Yeah. Nice.
Yeah. So this is pretty much how this works. All right. The effects. You have different types of effects. There are the constant force, ramp, square, sine, triangle, two sawtooth effects, spring, damper, inertia, friction, and custom, which is not used. These are effects defined by the physical interface device standard. And back then, when it was designed, devices didn't have a lot of bandwidth for communication with the PC. They were controlled via MIDI, for example.
Sure.
So this means the device should calculate the effects as much as possible. So a sine effect, a spring effect, has, for example, a few different parameters. So let me open up this old tool. This is also a really old tool from Microsoft. Actually, it is from 1999. So I can create a spring effect now. And it has the parameters coefficient, saturation, and offset. This was also what we set in the other device.
Yeah.
So the offset says where to rotate the steering wheel. The coefficient is how steep the spring should be.
When you say steep, you mean like how strong?
How strong, kind of.
Okay. Yep.
It is. Okay. This tool is not that user friendly. So how strong the spring should be.
Okay. Yep.
And how fast it should ramp up. So a spring is pretty much the formula position minus offset, so the difference, multiplied by the coefficient, and then clipped to the saturation value.
Okay.
And this is calculated on the device at 1 kilohertz. So this is a really smooth effect. This is one of the conditional effects, because the condition is the position of the spring. more of the conditional effects are, for example, the damper, inertia and friction. Damper, the condition is depends on the speed the steering wheel is turning at. So a damper effect will just make the wheel feel heavy, right? So
Got it.
and then there are also some periodic effects like a sine effect. This just wobbles the wheel back and forth. This plays a sine wave.
And these are all predefined notions of what these effects should be.
These are predefined effects in the PID standard. Yes. Because
That's so crazy.
if you want to play a sine effect on an old device, which is MIDI controlled, you cannot just stream the data. You want
Right.
the game allocates first the effect, says what the effect should look like, and then it
Yep.
can send a play command, and then it plays the effect.
Got it.
This is part of
But
the
it's a
HID standard. Yes.
predefined effects with a couple parameters are defined in the spec and no changing them. That's amazing.
You can change the parameters of the effect, but the
Right.
formula how the effect should look like a sine effect should be a sine, right? With a
That's amazing.
certain phase and offset, so you can change the
It's so funny because I know
period, the
almost
phase.
nothing about these force feedback steering wheels, but I did get to sit at one at a micro center the other day, and I recognized it was something high end. It might be one of these what are the Simu?
Maybe SimuCube or Fanatec also has some direct drive
It was
wheels.
like a multi-$1,000 setup just for this. I think the steering wheel itself was over $1,000.
Yeah, the SimuCube 2 Pros, they are around 1,000, 2,000, depending on which one you get.
Yeah. And I recognize every single one of these effects from sitting at it for 2 minutes.
Yeah, which might be funny because these effects I'm currently talking about are not used by games at the moment.
Oh,
Most of them are not.
how does that work?
So what games are now using is something called the constant force effect, because this actually allows the game to really define in real time the force. The constant force effect just has no parameters. You just send a force, and this is the torque, and it gets sent to the motor driver.
Ah, okay. So it's allowing it to do real-time effect feedback.
So with constant force, the only thing you have is the strength.
Got it.
So the game says allocate constant force effect, and then it can just internally calculate the actual wheel forces from the car and send this in real time to the steering wheel. Of course, via MIDI, this would not really work. With USB, you can send it at 1 millisecond intervals. Usually it's a bit slower. Most games run between 60 and 300 hertz. But this allows the game to have full control over the effects.
Got it.
And then they usually add a damper effect, for example. Because the damper effect, if it runs on the device, it is much smoother. But the game doesn't know how it will feel in the end. This is the problem with all these predefined effects. They are quite vaguely defined. And the game developer would not know what the device makes of it.
Right, sure. Because it's all up to the device manufacturer to interpret what a given input should look like.
For example, just defined a full-scale damper effect should make a strong damper. But how strong? Is it even supported? The game developer doesn't know. For example, SimuCube, until recently, I think 3 years after they released their 2 Pros, they did not even correctly support the spring effect. Like they did not support, I think I have a connection problem. Let's see. I think the connection dropped out. Can you still hear me?
I can hear you. Yep.
Okay. Yeah.
Yeah.
My stream froze for a second. Okay. Yeah. SimuCube.
We
Until
might have
recently, they
Obother ready.
did not.
Somebody let me know if Obother's ready.
They did not support the spring offset, so it could just do a spring which goes to the center, which is what most games use the spring effect for. And the rest is usually then the constant force effect. Yeah, and this is also what you can do with wheelcheck, for example. The force spring effect with PID. This is actually a PID-controlled spring effect, which reacts extremely fast because it uses PID control.
That's wild. And, all right, let's try bringing Obother in here and see if his audio is working. Hey, Obother, are you there?
It's a rare headphones moment. Can you hear me okay?
Oh, excellent. Yes, we can. Welcome, welcome.
Perfect.
Glad to have you here. Good.
I have everything pulled apart right now. I just did a different stream and just ended it. So I haven't had time to break down, but...
have you been literally
I've
working on your
right
steering wheel currently?
No, we did a music thing today. I was repairing modular synth parts. No, but I do have my entire wheel, all 20 pounds of it, right here. Look at it. There it is. Oh my God.
Great.
Okay. So it's awesome. A Mitsubishi Mel servo that I got off eBay because they have a shelf life in the factory where they want to replace stuff so that it doesn't break and they lose millions of dollars. So they replace these and then they end up on a shelf and then somebody ends up, absorbing them and putting them on eBay. So I got this for like $150. And so I have 2 horsepower Mitsubishi Mel servo powering the wheel. The wheel communicates to the steering wheel with a slip ring that we, made. By the way, Fusion 360 hates it when traces go in circles. It can't render the circuit board. But that slip ring brings LIN bus to the wheel that we had to reverse engineer. And the wheel is a Mercedes C-Class wheel because it has paddles on the back. I didn't know if I'd do the shifter or not for it. So it speaks LIN bus, and we reverse engineered LIN bus because you can do it in about 5 minutes. There aren't that many LIN addresses to pull.
What's LIN bus?
I don't know. It's a local interconnect network. It's an automotive protocol. All of the Euro auto places got together and they said, we need something cheaper than CAN bus. So it is very much like a one-wire protocol where you call out an address and then you get a response back immediately. So I ended up having to set up basically just a brute forcer to find the address. And this thing does backlighting. The wheel does backlighting. I don't know how to do it because I don't know the addresses that will do that. I guess I can flip the camera to another thing. But in addition to that, just because things were already LIN bus, I created a bunch of little circuit boards that have just an AT-Tiny85 on them, and then these speak LIN bus and plug in to, it's out of view. Hold on. Everything is so heavy. They plug in to actual car pedals. So these are BMW car pedals, and they don't speak a digital protocol default. So I made that module so that it could communicate with a load cell and Hall effect sensors and stuff to do the actual feel of real car pedals. And then in addition to that, we 3D printed a shifter, but the original shifter was actually from an E46M BMW, and you could like rally shift up and down with that. But yeah, Real Car Parts was the name of the game. I 3D printed an actual shifter with gates on it because I could not reconcile what forward and backwards shifting was. My brain just wouldn't do it. So I spent all this time and effort and discovered that I have more buttons than the SimuCube can actually express. Here's the, I'm out of breath from this. So I have a SimuCube at the bottom there, and on top is my own circuit board. And because Granite Devices kept saying over and over, oh yeah, we'll release an API. They never did. So I had to take matters into my own hands. I have a port expander, and then I have 2 analog, what are they? Potentiometer, or 2 digital potentiometers. Man, brain isn't working right. And then the Teensy 3.2 is speaking to all the external components, and it literally just flips switches. I got fed up with that though, and needed more buttons. So I have a TX and an RX plugged in right there, And that fools the SimuCube into thinking it's connecting to a Bluetooth low energy module. And that way I can digitally press buttons finally. But that was a huge, huge amount of reverse engineering the Bluetooth low energy stack, because nobody makes a program that fakes being a Bluetooth low energy TXRX. But anyway, we got it all working in together, and I use it to play my summer car. And that's about it.
And so the SimuCube is your interface to the computer? That's doing all your conversion.
Yes, the SimuCube is what I wanted to have one virtual or one joystick to be the whole setup, and that's what the SimuCube does. It's got I guess it's got very similar to the Open Wheel. There's a lot of dust in here. Similar to the Open Wheel project, it uses the STM32, and it plugs it into their proprietary controller. Because people were taking the STM32 board and they were plugging it into these controllers, and Granite Devices just went, we can make a board that does that. So they did, but they didn't give me any digital API to speak to pressing buttons. Yeah. Of course, my summer car limits the number of buttons you can use anyway, but but yeah, so it was a huge effort, and I've used it on 2 or 3 streams. That's it.
That's the way it goes with these sort of projects, right?
What I was seeing with the software over there is something that I think I need to flash to this board, because it looks like it's much better than the Granite Devices software. Because you basically have 2 devices on this board. One of them is the motor controller card, and the other one is the STM32. So if I can reconcile how that thing is all connected, I would love to explore some open alternatives and then junk all the code that I made to fake being a wireless wheel. Throw it in the garbage.
Yeah, with the SimuCube. I mean, they partially had it open source, kind of parts of the firmware, but they took it down now.
Yeah, the API is a blank GitHub page, and there's no, I couldn't use the Wayback Machine to find it. So I have absolutely no jumping off point for reverse engineering any kind of an API. Well, very frustrating.
The Simple Motion protocol, they still have it, but the SimuCube firmware, they had it partially open, but removed it when they released the SimuCube 2 Pro wheels. Because, I mean, I don't blame them. They want to be a commercial option now and, protect this.
Just a one-stop thing.
Which I currently don't care about, so it's open source stuff. On the topic of reverse engineering, BMW parts, I have this BMW cluster, which was reverse engineered pretty well, and you can pretty easily control it. And someone in my community made a plugin for SimHub, right? SimHub, which is a dash control software, and it talks through my OpenFFBoard to this CAN-controlled instrument cluster. So on the last Maker Faire, I had this mounted on top of the steering wheel, and people, it really did work, but it is kind of experimental. But if you are interested in something like this, this one is pretty well reverse engineered.
Anything BMW is extremely, they have some really freaky fans of the cars. I've seen all of the memory addresses of my own ECU in my old car. These guys are psychos. So yeah, anything BMW you can find all kinds of information on. I really want to know what the backlighting signal is for that thing though.
It's also really cheap. This one, I think it was 25 euros or something, or 30. It was really cheap. And you can get them all day long for this price. On the other hand, Audi and VW stuff, they have the immobilizer in the dash. So that's an issue. I have a Mark 1 Audi TT at the moment, and a very common defect is that the LCD breaks. So many people on the forums, they talk about this and say, yeah, I mean, just buy a new one. Go to the Audi dealership and buy a new one. You know, these cost 1,000 euros. and then costs maybe 500 or 2,000 to let the dealership reflash them with your immobilizer stuff. You cannot just swap it. And
the immobilizer is some sort of crypto pairing with the car, so that you can't.
Yeah, it's like a secret key that gets shared between the modules over, I think, CAN bus or its own thing.
I
and
hate that crap.
If the numbers don't agree, your car goes, nah, no thanks. I had to do this with the ABS module in my car. Just recently, you have to go in and use some really cryptic programs in order to get the VIN number into the module so that it will work with everything else. Yeah.
This should be illegal.
Lucky for me, all those tools are free now. But back in the day, you'd have to go to the dealership and be like, hey, I need you to code this to my car. Otherwise, it'll think I'm trying to steal it.
Yes, this is
I think this is unjustifiable on the parts of the manufacturers. It really needs to be. I mean, this is what we need in right to repair laws. Is no more pairing of parts like this. It's absurd.
What I did then, I took it apart and just got a new screen from AliExpress for $10, and just resoldered it, and it works fine.
That's awesome.
But I mean, people on the forums, I shared this, how to do this, and some were actually angry about it, because why would I do this myself? It's so risky. What if it breaks? And so on. And just pay someone to do it. Yeah, I mean, they are the same people as I am. I want to document it for people who know electronics, who know what to watch out for. So, for example, you have to be really careful to put the needles back on correctly and calibrate them, right? And where all the plastic clips are and so on.
Okay, that's fair. Yeah.
They always
swapping
break.
the screen is just, I mean, pretty standard soldering stuff. It's not that hard, but the difficult part is to get into there without breaking it.
Yeah.
And if you break it, then you have a problem, because this is what allows your car to start, right? Yeah.
Better view of my not Mercedes.
Really cool.
Oh, that's a really cool setup, brother.
So there's that, and then the pedals, I guess I can kind of get in view. If I knock my headphone cable, my audio stuff might go wonky. I just put everything into a rack case, and I've got growing pains. All right, hello. Okay, there we go. So the pedals, I mean, the BMW accelerator pedal, possibly the most used part in the BMW, is the easiest thing ever. It's basically just has two redundant voltage outputs that swing from VDD to VCC. So it's got this beautiful clean output out of this thing. So that's just the voltage level. The brake pedal, I had to do a little bit of, why is it so squishy? I guess I made it squishy to mimic my own car, my own crappy car. So it has a big spring. Let's see if I can show big spring. I'm fighting my setup right now. Okay, let's see here. Where's big spring? There's a big spring and a plunger in there. And then the plunger is just a typical load cell. It's kind of actually hard to show. But I have a stiffening rod right here so that the whole setup doesn't bend when I'm emergency braking. And then the clutch pedal is just a Hall effect sensor and a bunch of springs. I can't get my stupid camera. Hold on. Just please just reach. Okay, there. There's a spring there, and then there's a clutch assist spring as well. But all that does is just mimic the feel of a clutch. And then I have a little Hall effect board sitting right there that'll figure out what the position is. So all of that goes to this wonderfully mounted circuit board. I really need to work on that. And that communicates back to the rest of the stuff. Okay.
That's awesome.
That's the 3D printed shifter. I did a lot of modifications to the models. I learned how to take stuff and make them into fusion solids. And then this right here, this little add-on, I guess I can't get it out of this if I unclip it, but it just presses in place. We reverse engineered the reverse lockout. It's like a roller on a spring. There's a sprung roller and then a ramp that goes into it. And so I can find first gear like a normal car and then press it over and it goes, bump. And now I'm in reverse-ish. I mean, sometimes I don't assign that, and so it's reverse or first gear. So that's that. The designer of this on Thingiverse put enough bearings in the bottom of this to make the shaft that holds everything together just a freewheeling shaft. So we had to modify out all of the bearings and make it actually make sense. And then I use RC car struts to give it kind of a little bit of a damped feel.
With the springs,
a lot of,
like you would put in a suspension.
Yeah, it's just got a little oil damper in there.
Nice.
The horn does work, but this is a airbag cover from a BMW. So I just kind of stuffed it in there with some foam. But the reason I chose this wheel was it's got an up, down, a left, and a right button. So I can navigate menus with it if I assign things properly.
That's amazing.
Yeah.
Well,
someone
chat was saying that clearly Yannick needs to inspire you to add an instrument cluster now.
An instrument cluster. Oh no. I don't know
believe
what I
the
do
exact
about that.
words from Jalopy Jones were yes, Yannick, give him more to add to the catastrophe. That's the exact word in there.
I need to staple down all the wires first. I'm working on I'm working on making this board, and actually if I look at open force feedback wheel, I might not need all of this, but I'm currently designing my own circuit board for this that will also incorporate a USB switcher, because there's the Arduino, there's the two on this thing, and I can't really, this thing is mounted under my quote-unquote floor plate on the pedals. There's just a piece of my old computer here, just a door, and that is where that mounts. This is actually a laser power supply box that a friend of mine who has a big shop just gave me. He's like, here, you want this? And it was filled with transformers. Half of it is the power supply for this infernally powerful wheel. It's a workout.
Yeah.
Even just setting it up.
Yeah.
But yeah, the reason I have such a big pedal rig like this is that it needs to actually attach to the chair. Otherwise, I will push myself or it into a place it's not supposed to be.
Sure. Yeah, you need something to push back against.
Yeah, that
Even
was
still,
also
this
a
is
problem.
This is canted to the side because of the force that this bar puts into it. So these are a little bit like the holes have they're an oval, so it's basically pushed itself like that. Why are we creepily zooming in? Ah. It's my baby, but it's also a pile of garbage.
How big? This is a question for both of you. How big is this community of people home DIYing, steering, force feedback rigs?
I have absolutely no idea because I don't really communicate with the community. I look at forum posts from 6 years ago where somebody says, "Never mind, I solved the problem." So I mean, that's just that's my interaction.
Maybe it's more of a question for Yannick then.
There are a few forums where I also read initially, like on Xsimulator or some local forums. That's okay. The camera. There are some forums where people share their projects. At the moment, since I made a Discord for just my project, and I think a few days ago it surpassed 2,000 members already.
Oh wow!
So
that's
it does
much
seem
bigger
to
than I
be
would have guessed.
quite a bit of interest in just this one project now.
Yeah.
And of course, there are other similar projects and people who are not joining any Discord servers or forums.
Yeah.
So overall, I would say the DIY sim racing space, it is pretty large, because people are always, they are building their own sim rigs, of course. There are some commercial options now, but many people just want to build it themselves, or they say they're not happy with the commercial options or it's just too expensive. So
yeah, too expensive is really where I came from. And, I was building something stupid to play My Summer Car with. I was like, this game would be easier if I had a wheel. And, it's not a racing game. I've done a couple racing games with the setup, but I haven't had time to sit down with it and learn what all the feedback settings are and how to kind of wrestle it into a functional area in the game. So when I played My Summer Car with it, it was neat to have force feedback, but there were enough weird errors that I just disabled it and just had the return to center spring on the wheel, and that's it.
Ah, okay.
And that because you're not gonna do better in a racing game with a wheel. You do worse because you have to fight the feedback. At least for me, because this thing is obscenely powerful, which is funny.
Yeah.
But I don't do better in racing games with this wheel. My summer car is fun to play with this, and you do a little bit better in aiming your car around, but that's just that game. All of these components, like the professional stuff, has this sort of like automatic high percentage extra cost to it. Even the bracket for this motor I had to get from Scandinavia at a great expense. And that's just to hold up a standard motor at a slight steering wheel angle. So doing the DIY approach means that you can buy your stuff piecemeal. You can find stuff like, people will always be crashing luxury cars, so I can find the steering wheel everywhere. I can't find the airbag the airbag cover for this wheel, which is related to what I just said. I mean, honestly, people are crashing these cars all the time. And so they take the wheel and somebody refurbishes the leather, gets the blood off of it, and then I buy it off of eBay for pennies on the dollar. Stuff like that. And one of the more interesting facets of this, at least for me, in my perspective, is that I get to reverse engineer all this stuff. So I get to actually flex my muscles a little bit. I know the general consumer isn't interested in that, but I mean, when you have sort of a piecemeal amalgamation of different parts and stuff, you're going to have a very personal and strangely set up. So they're all going to vary, and yeah, there's a lot of really interesting projects in these that I love.
Yannick,
it's a very personal setup.
How much would someone spend to build a steering wheel setup like yours with your open source project?
So it really highly depends on the components you want.
Okay.
It's always a trade-off between quality components and how much time.
What's kind of the minimum you would need to spend to get something that would be fun to play with?
I would say a reasonable setup with new components and standard motors would be about 500, 600 euros.
Okay. And what would the equivalent commercial product cost you?
I would say with this one, you would be in the SimuCube 2 Pro range, which costs 1,500, kind of like this.
Wow.
So, but there are some cheaper options. So if you want to go commercial, Fanatec currently has one for, I think, 300, but it's a bit weaker and it's hard to get. So there are some cheaper commercial options available as well. With DIY, you are not necessarily cheaper, but you can piece it together however you want. So a big cost factor obviously is the motor. If you are buying a new servo motor MH130ST from China, shipped to Europe, the motor costs around 150 euros, but the shipping also is 150. So 300 for the motor.
So heavy,
With my route, I went with the Mitsubishi Mel Servo off of eBay, which was roughly equivalent in price, although you have to spend like $30 to $50 in shipping because these things are made out of metal. So they're extremely heavy to ship around. And then the encoder speaks Mitsubishi, and apparently I saw a listing for one online, just the encoder. Sells for like $380 because it's an industrial part. I didn't bother to reverse engineer it. It was basically like a CD disc, like a plastic CD that had all of these microscopic markings on it that were read by an optical encoder. Cool part. Took it off, threw it out, broke the disc, and then you just have a rotating shaft. There's a company, CUI Incorporated, that makes sort of a capacitive, position encoder. And those are really cool and versatile. I took one look at it. Yep, that's one of the better ones, yeah. And so those mounting points, those two little wings on the sides, matched up exactly to the bolt pattern of the old encoder. And then CUI has a bunch of little adapters that you put on in order to couple it with the shaft. And that was it. It was the easiest part of the whole project. And I was just showing your one belligerent chat member that BMWs do have turn signals. See, here's one right there. There it is. That's mine might not, but I'm not answering that question right now. I keep it right here, just to remind me. Okay, maybe I keep it right there.
I think my
Fell
camera
off the
died.
desk.
That's awesome.
Looks unused. All right, I'm out of here. I'm
It has to
leaving.
be fake. Yep.
It's actually kind of cool because when you turn on the turn signal, a little plastic nub pops out right there, and that can
Right.
move in one direction without triggering anything. And if it moves in the opposite direction, that clicks over and then returns to position. So it's
I
just this
wondered
little
how that
nub
worked.
that pops out, and then something on the steering wheel tickles it, and then it pops back into position.
Okay.
Yeah, I
goes
always
away
wondered
when
how
it's
those
done.
worked.
Yeah. Well,
That's
that's at least
awesome.
this design. I'm sure there's many other designs, but
Yeah.
the E46 series does it that way. Pretty cool. Never going to use it, but I could add them to the setup. I have both of the turn signals. The only problem is the signal coming out of the turn signal. In order to save wires in an era before, I guess, serial communication was the way to go, in order to save wires, what they do is there's just a resistor ladder inside of the thing. So when you choose the different positions, for at least for the windshield wiper, you have a bunch of different positions for the speeds of the windshield wiper. There is a wire that carries a variety of different voltages stepping up to whatever speed you've got the windshield wipers at. It doesn't directly control
That's
it.
clever.
Maybe it did in an era previous, but it communicates with another module that then does the motor control. Which is
That's
it's just
clever.
a simple universal 12-volt motor, but still, they in order to save on wires, it's a voltage level signal for the different positions.
That's really simple and awesome. Yeah, I wouldn't have thought to do that. That's super clever. Yannick, you showed off a joystick. Is the idea that you can also do this with multiple axes on like a fighter
Yes.
pilot or a helicopter joystick?
So let's see if my camera works again. I think
Yeah.
it shut down. Yeah. So yeah.
This is directly related to a project that I'm looking at.
Awesome.
This
Awesome.
is directly. Hold on, I gotta go get toys.
One of the members in my Discord community designed this joystick and this one back here. And I think they are selling kits at the moment for it, but it's still kind of in development. But it is using my control module as well.
Yep.
And so this one is pretty much just the O-Drive motors. I plan to use it, even as the O-Drive logo. So I plan to use the O-Drive at first, like the 3.6, because it makes sense. But initially, when I designed the Team C driver, I also planned to stack multiple of them together. So finally, after more than 2 years, the first time I stacked two Team C drivers together.
Nice.
This was kind of a failed prototype. I have not shown this yet. I'm working on a video about this where I explained it more. But I just didn't assemble all the components which are redundant on this one, like the voltage converters and so on, and just had the required components. So in this case, I now can connect two axes with this board. Let's see if I can turn it on, then I will shut this down because it's loud.
So where is can you show where the two motors are?
Yeah, I can. Let
In
me connect this first.
Yep. Sure.
Okay, right. Right, it's not working at the moment. All right. It's still making force feedback. The alignment is a little bit problematic because the Team C drivers are not made for these motors. So
Oh. Got it.
here are the two motors.
Oh,
One
I
is
see.
here, one is here. And they are using this belt drive.
Yeah.
And on one side is one of the CUI encoders we already talked about. And yeah, this is pretty much just a pulley then. I have not designed this. It was a member of my community.
Beautiful mechanical design.
And
Yeah, it's really cool.
It's really simple and very solid, the
Yeah.
design. And also extremely strong. So
I guess slightly less relevant to my own endeavors. This is something that I've been working on from a long, long time ago. This is like a dual joystick setup, and it's actually where my wheel got the mount that clips it onto the side of a table. This is basically a left-handed warthog that somebody painstakingly created, like with molding supplies. So I wanted to have the two joysticks and the throttle, and then I had a set of pedals from VKB, which I guess is a Russian simulator or joystick outfit, and they had their own little orange box that the pedals plug into. The pedals themselves had just a magnetic rotation sensor on it, and what looked like probably an AT Tiny 85 that had all the markings rubbed off, of course, which is always the worst thing that somebody could do. So we looked at the protocol that it was speaking to the box, and it was completely insane, bonkers, crazy go nuts. We couldn't figure anything out about what language that thing was speaking. It turns out taking half of the bits of one of the signal and half of the bits of the other part of the signal and XORing them together gave us an actual signal out of the thing. And that was after I was staring at numbers, just numbers forever in order to try to figure that out. I couldn't see any correlation between movement and the signal because of the XOR operation. So doing that gave us a good signal, and then I stalled on it, and the reason this thing is covered in 80 layers of dust is that I've been sitting on this project for 8 years. Well, because they don't want you to reverse engineer it. I guess that's all I can come up with. Because why would you do that operation in order to make it all cryptic? You would just have your signal and then a checksum at the end. But that's what I got after I XORed it. And when you do that, when you separate a signal like that and make it double the length, and all the bits are XORed, they don't flip in relation to one another in the way that you would think. It's very confusing. But that was part of the effort on that. But this is not force feedback. This is not that gorgeous motor setup. But yeah, I need to get back to this one. This was for Star Citizen, which luckily is never coming out. So I have infinite time to work on this. But I do want to get it done at some point. Yes.
This is also a VKB grip, and I do not have a base for it. So I started reverse engineering it like you did. And there was a single Reddit post for people who looked into this. And it is actually speaking half duplex UART. And it is also XOR kind of encrypted. Finding out the buttons was really easy because I know that the input is all buttons are not pressed. So I just XOR the bits of the buttons I know which are not pressed and so on. No? So this was quite easy to find out which bytes are corresponding to the buttons, but the analog axis, they are difficult. I don't have a complete solution yet. I have it kind of working, but the problem is with analog axis, you don't know what the input is.
Meanwhile, Thrustmaster just uses a shift register. That's it. Just a shift register, like a Nintendo controller, just a shift register. That's it.
This is also super easy. I have an actual Thrustmaster mode built into my firmware because it's just so easy.
Yeah.
But with VKB stuff, they want to make it hard to reverse engineer. I don't know why.
And why? It's not like they're going to sell less units.
Yeah, they don't sell less. But people would use it, for example, for DIY stuff when their own bases could not be used. And the bases they are selling, they are not that expensive. So I don't know what they gained from it by making it hard. Yeah. But I mean,
that's crazy.
Okay, it's not what I would do, but they also XOR scrambled the protocol of this just grip. I don't know why. It makes no sense.
It's so crazy.
Yeah.
It's so ridiculous.
This is also the other joystick, which is using some actuators with planetary gearboxes inside. Yeah. This is a little bit smoother. It still has quite a bit of cogging, but it's not that noticeable. But it also has some play. This one has no play, but it has a lot of cogging because, these motors, they do have a lot of cogging.
Yep.
Yeah, and to demonstrate it in the software, I have a force feedback joystick mode, so you can select main classes. I don't think you can see it at the moment. I have to switch this up a bit. You have different modes, like force feedback wheel, joystick, external force feedback, and shifter I'm currently working on. So I am working on transforming a joystick into an
God.
edge pattern shifter, where the
Can you
shifter
make it
gates,
bounce off of the synchros when you don't put the clutch in?
in theory, if I had the
Awesome.
feedback from the game, I could do this.
Yeah.
So that was the plan, to make a software-defined shifter. With
I mean, you probably could do it outside of the game, right? Because you could measure the clutch
You
position
know all
and
the elements.
and
Yeah.
the shifter.
yeah, probably. Sure.
Absolute torture mode where it makes a horrible grinding noise.
Exactly.
Oh, my synchros.
So yeah, this is actually the 2-axis mode with Ultrawipf, of course, it's easy. The Ultrawipf just speaks canvas, but it also supports the TMC now, which is a bit smoother in this case. But the TMC is not designed for these motors because they are rated for 50 to 100 amps, and the TMC, I have currently 30 amp sensors on it. The previous version only had 20 amp sensors, but I modified this one with 30 amp, so it can get a bit of force. But this one, it is so insanely strong. This joystick, it will break your fingers if you are not careful. It probably can do 20, 30 Newton meters if you really push it.
Do you have to be pretty careful when testing these?
I mean,
Because I imagine this could get fairly violent if you're
it can get
settings
very
off or
violent.
a minus sign in the wrong place.
Yeah, initially I did have some close calls with the steering wheel just jerking around while debugging, testing. Usually it's quite safe if you know what you are doing. While testing the shifter mode, I did have the issue that I had the force inverted. So it slapped away from the center instead of in the center with full force. Yeah. And it was set to 25 amps at the time.
Yeah, these things happen in games. Sometimes it's just badly interpreted. And, I have, in the Granite Devices stuff, you have to flip the feedback, I guess, direction or whatever, like the input direction, in order to get it to sync up with the game sometimes. And even alt-tabbing out of the game and coming back in can upset that. And so you get all kinds of weird things where your wheel gets so much easier to turn the further away from the center locking point, or if you have a detent in the center, it'll just jerk out of the way. I've had times when the wheel has just sort of gone back and forth because some PID hasn't initialized properly. So you have to be kind of wary of your own setup when you you keep your thumbs out of the wheel when you start up.
I mean, it seems like it's one thing on the steering wheels, but at least with the steering wheels, you're not going to damage the wheel hardware if everything goes out of control. But it seems very much like this stick setup could directly wreck itself.
I mean, as long as you don't have a wire connected to the steering wheel. Most people don't use slip rings; they have wires connected to the steering wheel. So if it spins out of control, the wire will not find this funny.
I did the slip ring very specifically because of the weight of this thing. I need to use the wheel to move it around. And if I'm moving 18 pounds by the wheel and it goes too far, it will, wreck what's usually called the clock spring. It's basically a flat cable that wraps one way, doubles on back on itself, and wraps the other way a couple times. Because you can't, in a car, there's all kinds of mechanical stuff that will not allow you to move the wheel 180 degrees, whereas this, or whatever it is, 3 turns.
The steering system will provide
this is just, when it's off, it's just completely loose. So if I put a clock spring in there, there's plastic that it would hit up against to stop it that can't overpower 18 pounds of force. So I had to invent a slip ring. And that's why the wireless wheel module is such a thing from Granite Devices. So,
Yeah.
Yeah,
Makes sense.
Bluetooth makes sense in this case. It's just much easier. But I still prefer wires. But the problem is, I mean, you probably have seen how expensive slip rings can be. And big slip rings,
oh yeah, because they're an industrial
they are
part.
really expensive.
This is
Pay the
cheaper.
industrial part tax.
Getting a custom circuit board made that fits my needs with 3 giant traces on it, I think was in the upper 60s, maybe 100, but it was cheaper than getting a slip ring. They're ridiculously expensive. And so I took apart a couple Molex connectors and soldered them to the tracks, and it's just 2 of these boards up against one another. And I had to use, what is it called? Electrical grease. I can't remember the names of things right now. As an interface, otherwise this thing squeals. I don't know how much wear and tear there is on the one in there because I have to remove the whole wheel in order to pull it apart.
What's the contact down to the circular traces?
That's what I took apart a Molex connector, and they have the type of Molex connector that I took apart has like a sprung pin. So it's just the whole pin is a big spring that goes up against what plugs into it. And I soldered that down to the exposed trace on one of them, and then on the other one it just goes up against it.
I got it.
Yeah,
got it. The one
and
stationary, one's
there are
moving.
there are very complicated wiper designs for things like this. In much larger installations, they just have something that's akin to desoldering braid that just sits up against the spinning thing. But in my case, I tried Molex connectors, and actually Flatulent Gonad, who's in chat, made a very quick board and put it on a record player and had that spinning just to do a proof of concept in like 10 minutes.
Nice.
But yeah, I built this in Fusion, sent it off to a board place, and then this soldered a couple connectors to it and made my own slip ring for pennies on the dollar compared to what these things actually at this size sell for. It's
what
wild.
was the slip ring you were showing, Yannick? Or was that slip ring?
Yeah, that's a commercial slip ring, and I wanted to show the difference. So yeah, this uses some tiny brushes in there, and this one costs 150 euros a piece.
I wasn't able to source anything. Like I looked around and just could not find anything to source. So I DIY'd it instead of spending like $300 on something like that. I'm like, it's just a wire. Why can't we do this? So
the problem is the wear. With a PCB, you would need some thick hard gold plating, and that's a really expensive process. That's the problem in this case. Sure, you can just use normal plating, but it would probably wear down pretty fast.
Wear through it eventually. Yeah.
So this is why even PCB slip rings are so extremely expensive. I checked what their thicknesses usually are. Yeah, and if you want to order it, for example, on PCBWay with this thickness of hard gold, just getting the PCB process done is a few €100 just for the setup already.
Wow. I didn't realize
it's just really expensive.
Yeah.
Because it's a special process.
Yeah.
And really
the problem with the phone dewinder is that these motors are not hollow. We can't get a wire through the center of the spindle in order to get those wires out. So you have to use something like the outside slip ring like that, or any of a number of other designs, but or just go wireless. I didn't feel like plugging in my wheel to recharge it. That's why I went through all of this trouble. A minor inconvenience leads to a 6-week project.
Yeah, I know this. I mean, usually some manufacturers like Fanatec, they do have a hollow shaft and pass the wire through. They even had an optical setup, not a slip ring, which was quite interesting. But yeah, getting motors with hollow shafts is pretty uncommon, and that's not something you can easily just buy. Yeah, it would be specially made for a steering wheel then, and not just some industrial stuff. That's the problem. Simulcube also has not a hollow shaft. They have a solid shaft, which is why they are using the Bluetooth solution in this case.
Yeah.
Which makes sense, makes it much easier. Fitting a big slip ring in front of the motor, I mean, it could be doable, but it's expensive and would make it difficult to flange mount the steering wheel. So it's usually the better solution to put the slip ring in the back, but
So what
or
are you
just go
using?
wireless.
What are you using to mount the wheel? Because on mine, I have what was a coupling that is not meant for this job at all. This coupling is your typical industrial, like a pulley would fit over this ring. This ring is split because you bolt into it a tapered whatever. This is tapered so that it puts pressure on this, which will then put pressure on the shaft, which will put pressure on the pulley. And it's a really nice mounting system that I'm allowing to return to Earth. You can see it rusting. But I ended up making a plate and then drilling 3 holes into the side of the plate. And I bought, for $20, a Mercedes steering shaft and cut it on a bandsaw. And then, so now I've got the spline mount there, and there's a giant bolt that goes to the center of that. But this is a nightmare. But it works. But
So yeah,
selling your DIY version for about $50. I tried to weld this, and when I got it downstairs, it just popped apart. I suck at welding.
So I tried 3D printing some first, which kind of worked with the stepper, but of course it breaks at some point. So printing was out of the question. No, what I bought is just an industrial shaft clamp. I'm not sure what the English name for this is, but there's just a taper inside which bolts in and squeezes around the shaft. They cost, I think, 20-30 euros or something. And then this is a laser cut steel plate adapting it to a wheel pattern. And same thing also here, just in tiny. Maybe you can see it. It just bolts together here and squeezes around the shaft. This,
it's not a set screw. It's
like this. So these are going through.
Yeah. Same principle
Squeezes
behind what I did, I guess.
This together. Yeah, probably the same thing.
I just don't have a thing going on the outside of this. So it's technically, I'm relying on this like a C-clip to clamp on the shaft, whereas in an industrial environment, you would have something surrounding this. So it would all be pressure. And actually, the cool thing about these couplings, you take the bolts out and you put them in the next set of holes, and it pushes apart the 2 pieces.
Yeah.
So when you, one side is threaded, it's like each hole is threaded and then not threaded. And then each hole in this thing is not there or threaded. So you go through the ones that slip in order to bolt it together and put the pressure on it. Then to take it apart, you have threads that will let you push against this and pop them apart.
Yeah, then it pushes them
cool little
apart
detail.
again. And on this one, I mean, this is just a hose clamp. And this is also fine. This is the simpler version. Also
Excellent.
And it's on a rubber. What's underneath the hose clamp? A rubber split fitting?
No, this is steel, also an industrial clamp.
Okay.
But a little bit simpler.
But what's the black? The black part is steel?
Yeah, the black part is steel.
Okay, got it.
And then this is laser cut wood.
That's awesome.
Yeah, because some of these motors, when you get them, they don't have a keyway on them. They're just pressure fit.
Can I put this back on?
Yep.
Not sure.
And machining a keyway would be a pain in the
I'm
butt.
just putting the steering wheel down here. And then there's also the 3D printed version on this stepper motor, also using a hose clamp and a solid printed part, which obviously broke apart at some point. And this is actually what Thrustmaster uses on their steering wheels. So, not sure if I can take this off. This is a huge threaded plastic piece, which is pushing this part and this part together. So this is what Thrustmaster uses on their commercial steering wheels. Let's see, maybe I can take this. Yeah, I can take it off.
I think I understand.
So it's there's also something you can find on the Thingiverse, just a massive plastic thread. And this is also their SPI connection, just a mini DIN plug. Yeah.
That's super cool. Well, guys, this is super awesome. Thank you both for coming on the stream. Oh, Bother, thank you for coming on such short notice.
Yeah, thanks for having me. I was
from
shoving salad in my face.
Yeah, no, this is fantastic. I've always really enjoyed your streams, and to have you as a guest is a pleasure. So
I'm honored. Thank you very much.
And boy, talk about the perfect stream to have you join. So
I can't believe that both of us independently reverse engineered a device that makes the other device think that it is a Bluetooth low energy modem connecting to a virtual Bluetooth low energy module. It is the weirdest, because nobody does this. And if I ran across the GitHub, the Yonex GitHub, I would have been like, this isn't the right thing. I need to do this myself. And it was a huge effort of timing and signals and just more like, I don't want to look at another like microcontroller program for a month after finishing this. And then it turns out in the end, there's a slight delay on the buttons, and my summer car doesn't take that many inputs, so I can't use them anyway. Because it's the, you know, the person who made my summer car made it. It was one person making this whole game, and so they only use a short subset of buttons. The way Granite Devices made those extra buttons come in, they're in a completely different bank that's like many, many buttons away. So all that effort, I could have just gotten the GitHub. But yeah, absolutely crazy. Absolutely crazy that we both did that.
Yeah, that's amazing. Well, everybody, please go check out both Yonex and Obother's different socials. And we've got Obother's Twitch on here. How often do you stream, Obother?
It should be Tuesday, Thursday, Friday, sometimes Saturday. It's been a little breaky uppy. I got a dog and I've been taking care of that. But yeah, that's Tuesday, Thursday, Friday.
Please go check out Obother.
12:30ish Eastern Standard.
Okay, awesome. Please go check out Obother. I've really enjoyed your streams. You're a fun guy to hang out with as you're working on projects. And then definitely go check out Yonex's YouTube channel. You've got a bunch of videos, Yonex, about how you've made all this and kind of your journey of this, as well as you've got a GitHub and a Hackaday.io page on this project.
Yeah, and also a Discord if you want to join.
And Discord. Let's get the Discord link in here as well. So if people want to learn more about this and interact with other folks.
The Discord link is also on the GitHub, but
okay.
I can also paste it in the chat if I'm allowed to.
Yeah, go ahead. If it doesn't let you, we'll get a mod to do it. Okay, cool. Awesome. And then of course, the Strange Parts Discord. You can find Discord GG /Strange Parts. So come hang out with us there. And yeah, we've got tons of other projects that people are sharing in the Discord, like this one. And I know, Yonex, at least you hang out in the Strange Parts Discord, right?
Yeah, sometimes.
And I think we convinced Obother to at least join, but I don't know if he's going to hang out there regularly. Hopefully.
We'll see. No promises. No, I'll definitely hang out there. Are you kidding me?
I understand. I'm in 20 Discords as well, so I get it.
Yeah, it's a list.
Yes. Yeah. It's hard to stay on top of everything. But yeah, thank you both so much for coming on. And to everybody out there, if you have a project you'd like to share, please sign up. It's strangeparts.com/show-and-tell. And it's just a Google form that quickly tells us what you want to show, and we'd love to have you. So, yeah. All right. Well, with that, I'll sign off. Thank you both, gentlemen, and we'll see you. I'll see you again soon.
Alrighty, take care.
All right. Have a good rest of your weekend.
Bye.
Take care. Bye. Thank you all. This was amazing. I'm looking forward to doing more like this. We're going to have multiple guests on in the future like this. That was 10 times better than just me and one guest. So we'll have to figure out how to make that work. Take care. I'll see y'all on the Discord. Have a good rest of your weekend.